Okay, I'm going to revise with you Mathematics Paper 1, 2022 in 10. So you can watch this video up to the end. My name is Franz Piri, and I am going to answer a question, the last question in Mathematics Paper 1, 2022. Okay, ECZ. So let me just show you the question. So allow me to rotate my computer like that, then I show you the question. So this was the question. Okay, the question is saying let me do this. Okay, so the question is saying the diagram below is the speed time graph of an object. The object starts from rest and accelerates uniformly for 2 seconds until it reaches a speed of 10 meters per second. It then travels at this speed for 8 seconds and finally decelerates to rest after 5 seconds. So that is the speed time graph you are seeing there, but I'm going to draw it so that you clearly see how it's looking. Then the first question is saying we find the retardation of the object in the first 5 seconds, then the distance traveled by this same object in the first 10 seconds, and the average speed for the whole journey. So let me just draw this graph. Let me draw this speed time graph. So it means I'll get rid of this question paper, then I draw my speed time graph there. So you're supposed to draw the speed time graph like that. So the first thing you have to draw the speed time graph. So I'll draw my speed time graph here like that, then like that. Okay, then you put the dotted line like that, equal this side the dotted line like that. Then this object started from zero, from rest, so you need to put a 0 there. Okay, it started from rest here, it started from rest and then it accelerated like that, and then it moved at a constant velocity like that, and then it retardated like that. So that is that. Then the next thing is this side here we need to have the speed in meters per second, then this other side we need to have the time in seconds. So I'll put my speed there, speed in meters per second, then down there I'll put my time in seconds. Okay, then we can now proceed by putting some numbers there. Need to put numbers there equally that side there. Okay, so I'll put 2 there because that there was a 2 there, then there 10 and 15 there. In that side we had 10, then you can even put the dotted line like that there. Okay, so this is the speed time graph that I've drawn. Okay, so this is how it is looking. This is how it looks like. Okay, we can now answer the first question. So what was that first question? So the first question was saying retardation in the last 5 seconds. So try to analyze this graph. Try to analyze this speed time graph first. when you clearly look at this speed time graph, we had first we had this object started from 0 there, and then it started accelerating. Accelerating. Then here it moved at a constant speed or velocity, and then it retardated like that. So now they are saying we find the retardation in the last 5 seconds. So meaning that the last 5 seconds this object started retardating from there. So it means the last 5 seconds is between here. So you subtract 10 minus 15 minus 10, and then you get that 5 seconds. So let's quickly answer that first question. They are saying retardation in the last 5 seconds. So retardation, what you need to know is that retardation is the negative acceleration. Retardation is the negative acceleration. So when you say retardation, the word itself, retardation, means negative acceleration. So there's no need of, when you use the word retardation, there's no need of putting a negative there to your answer, because the word itself, retardation, means negative acceleration. Okay, that's very important. You need to know that. So let's answer the first question. It's saying retardation in the last 5 seconds here. So let me just write the formula. So the formula is acceleration is equal to velocity minus initial velocity, then over time. That is the formula. Over time. So now note that we have acceleration there, we have velocity there, the final velocity, and the initial velocity there. So when we say initial velocity, then we are talking about where this object started from. Where did it start from? That is what we are talking about. So when you look at this object, it started from 0 here. So it means that is the initial velocity that we have there. Okay, so now that is that. So let me just get rid of this diagram here. Okay, or I'll push it up like that so that we continue. Then we can now start substituting the values. So now when you look at this diagram, when you look at this graph, the acceleration, we are looking for the retardation, which is the negative acceleration. We are looking for retardation, which is the negative acceleration. So meaning that the final the object here, it is retardating. It started from retardating from here. Okay, this object started retardating from there. So it means that it had already the initial velocity, which is 10, because it didn't start retardating from 0, but it started retardating from 10. So that was the initial velocity there, and then the final velocity, it means this time around is 0, because it didn't start this object started from 10, so it means the initial velocity is 10 and the final velocity is 0. Okay, so we can continue now. You say equals the final velocity, will put 0 there, then minus the initial velocity. This object started from 10, he started retardating from 10 going down like that, so we are going to put 10. We put 10 there, then over the time they are saying retardation in the last 5 seconds. So we put 5 down there, we put 5 there, and then when you subtract now, when you subtract 0 minus 10, you get what? 0 minus 10, that is negative 10. Okay, negative 10. So negative 10 over 5, then this will give us what? This will give us negative 2 meters per second squared. Okay, so that is squared. Okay, let me just write that nicely. Okay, so negative 2 meters per second. That was the retardation. That was the retardation in the first what? In the rather in the last 5 seconds. Now, if you are tempted to write, if you are tempted to write R, which is retardation. If you are tempted to write R retardation, you are not supposed to indicate the negative there, because the word itself, retardation, means negative acceleration. So it will be just 2 meters per second squared. So there is no need of what? Putting a negative here, because this word itself, retardation, means negative acceleration. But when you put acceleration, is equal to, then you need to put a negative, because retardation is the negative acceleration. Hope you've gotten that. So when you put, this is how it's supposed to be. You need to put, if you've indicated acceleration there, then it has to have a negative there, because retardation is the negative acceleration. But when you put the word itself, retardation, then you are not supposed to put a negative. I hope I've made myself clear on that one. So that is what you need to know about retardation. Retardation, when they say retardation or deceleration, it means it's negative acceleration. Okay, so that is the answer for the first question. Then we can now move on to the next question. We can move on to the next question. Let me just remove this. The next question is saying what? Okay. The next question is supposed to be find the distance in the first 5 seconds. So let me just type the question here. Let me just type the question. It seems the question is lost here. I've lost the question. So the next question is the distance in the first 10 seconds. In the first 10 seconds, that is the next question there. Okay, so that is the next question, which is B. Let me just write, let me do this, please. Let me do this, sorry. Okay. I don't want to bring here the question, because that should take us, a little bit some time. So the next question is, distance in the first 10 seconds. So the distance in the first 10 seconds, where we have the first 10 seconds is here. So we need to find now the distance in that first 10 seconds. Now when you clearly analyze this graph, this in the first 10 seconds here, this is a trapezium. Okay, that is a trapezium. So now we need to come up with a formula for a trapezium. Okay, we need to come up with a formula for a trapezium. So let me just push this side. Okay, so the formula for a trapezium is, distance is equal to half let me write that properly, half, then open bracket, a, then plus b, a plus b, then height. So that is the formula for a trapezium. Okay, so now we need to answer this. We need to answer the second question, distance in the first 10 seconds. Okay, so now a here, the a you are seeing there is area under the graph. So the area under the graph is the distance from there up to there. Okay, that is the area under the graph. Okay, that is the area under the graph. And then the base is the distance from there up to there, meaning where this object started from up to where you are told to calculate the distance from. So the distance from there up to there, that is the base. So we are saying this is the base. Okay, so now let's proceed. We can proceed. The area under the graph, you need to subtract 10 minus 2 to get the area under the graph. So when you subtract 10 minus 2, you are supposed to get 8. So it will be distance is 1 over 2, then open bracket 8, then plus the breadth, or rather base, the distance from there up to there is 10. That is 10. Then closed bracket. Then the height there is what? This side, the height is the distance from there going up like that. So that is 10 again. Okay, the height was 10. Mind you, we are finding the distance in the first 10 seconds. Down here we have the time in seconds, so we are looking for the distance in the first 10 seconds. Okay, then from there now we can proceed. So you divide now. You say 2 there. Let me just use a different color so that you see what is happening here. 2 there is 1, then 2 there is 5. Right? That's 5. Then you say, so that is 5. then you say now 8 plus 10, you get 18. So this is equal to 18. Then here the brackets indicate the multiplication sign. The brackets indicate the multiplication sign. So 18 times 5, because we divided 2 into 10, we said it's 5. So 18 there times 5. Okay, 18 times 5. So when you multiply 18 times 5, that is what? So 8 times 5, that is 40. So it's 0, 0 carry 4. Then 5 times 1, that is 5. Then plus 4, that is 90. So that is your answer. Distance in meters. So 90 meters. So that is the distance in the first, in the first 10 seconds. That is the distance, 90 meters. Now we can move on to the next question. We can move on to the next question. The next question again has, disappeared here. So let me just quickly, type the last question. So the last question is average speed for the whole journey. For the whole journey. Okay. So that is a C, part C. Okay. So average speed for the whole journey. I'll just put it there. Okay. This time around now we are calculating the average speed for the whole journey. Okay. So now, do we know do we know the distance for the whole journey? No. For you to calculate the average speed for the whole journey, you need to have the distance for the whole journey. Now in this case, we only had, the distance in the first 10 seconds here. But we don't know the distance for the whole journey. We only had the distance in the first 10 seconds there, but we don't know the distance for the whole journey. So meaning, we need to know the distance for the whole journey. Okay. Then, from there now we can proceed. We'll say, let me push this side. Okay. So we are going to say distance is equal to half open bracket area under the graph breadth, that is too big, breadth, rather base, then height, then plus half again, then BH times BH. Okay. So that is the formula there. So the distance is equal to half area under the graph, which is A plus B, then height, then plus 1/2, then BH. Now, notice that in the first, in the first 10 seconds, we did not, include this part. which is 1 over 2 then BH. The reason was that this was a trapezium. This is a trapezium. So the formula for a trapezium, you just end here. This is the formula for a trapezium. Let me just use a different color here. Okay. So we are saying we did not include this part here. We just ended here because we are calculating the distance in the first 10 seconds. And when you look at this shape here, this is a trapezium. Okay. But this time around, we are including this triangle here. So the formula for a triangle is this one here, which is half then base times height. That is the formula for a triangle. So you need to include this triangle here. Okay. Then we can now proceed. We can proceed. So we'll say distance is equal. Here we are finding the distance first. So we need to find the distance first before calculating the average speed for the whole journey. That you should know, because we don't know the distance for the whole journey. So we need to know first the distance for the whole journey for us to calculate the average speed for the whole journey. So first we need to calculate the distance for the whole journey. So distance now, distance is equal to half, then open bracket, the area under the graph is the distance from here up to there. So area is this one, that is the area. So you need to subtract 10 minus 2, that is 8. So here the area under the graph is 8, then plus the base is the distance from there up to there. So that is 10. So that is 10. Then the height is the distance from there up to there. So that is again 10. Then plus half. Then the breadth for the triangle here, rather the base for the triangle here, is 15, meaning the distance from there up to there. So that is 15. So we'll say times 15. So allow me not to go up to there because I don't have enough space. Times 15. Then times the height is from there up to there, which is again 10, this one there. So times 10. Okay. Then from there now, we can proceed. We can proceed from there. Then you say 2 there is 1. Then 2 there is 5. Okay, and that is 5. Then 2 again there is 1. Then 2 there is 5. Okay. Then here now you can add what is in the brackets. 8 plus 10. That is 18. Then 18 times 5 there. That is 90. Okay. Then plus 15 there times 5, that is 70, because 5 times 5, that is 25, should be 75. Then 5 times 1 there, that is 5. Then plus 2, that is 7. So that is 75. Mind you, this is paper 1, so there is no need of a calculator. So when you add these two, 90 plus 75, you get what? 165. 165 meters. So that is the distance. That is the distance for the whole journey. So 90 plus 75, that is 165. Then it means that is the distance for the whole journey. Okay. Then from there, now we can calculate the average speed, because we now know the total distance, which is 165. So we can proceed now. We can answer this question, the average speed for the whole journey. Okay, this one here, the average speed for the whole journey. So now let me just rub this part here. Let me rub this part here.
Being late, it doesn't respect somebody.
Okay, so now the average speed, will say the speed is distance is equal to speed then times time. Okay, that is the formula for speed. If you want, you can make s the subject of the formula by dividing both sides by time. Then the time there will cancel. Then what are you going to have? Allow me again to just get rid of this. Okay, then when the time cancels there, you're going to have speed is equal to distance over time. That is the formula there. Then we know the distance, isn't it? Which is 165. The total distance for the whole journey, 165. Then 165 over the average speed. Now here, the time, we need to put time there. Now, do we know the time for the whole journey? Yes, we know the time for the whole journey. It was 15. For the whole journey, it was 15 there. So that is the time we are going to indicate there. So let's put 15 down there. Okay, 15. Then that will be equal to, when you divide 15 to 165, you get exactly 11 meters per second. Then that is the answer. So thank you very much, guys. If you've enjoyed this lesson, please share, comment, and give it a thumbs up. And also tell your friends about this the lessons that we offer here. You can as you go there in your exam, you can at least understand one or two things, so that you go there with your happy faces, and you don't have to get surprised when you see a strange question, or a question that looks strange to you. So you need to make sure that you study adequately as you are preparing for your exams. Thank you very much. Have a or let me say, God bless you. Okay, bye bye.